Alright guys, our last video is on exponents. Here we're going just the opposite direction and going with radicals. So everything you've ever learned about radicals and then some again, and just a great review. So hang on, let's do this thing. Alright, here's all the properties like we started the other day. You're allowed to break up radicals. If you have a single radical, you can break it up using multiplication anytime you want to. All right, and it also works the other way. If you have two radicals multiplied, you're allowed to multiply them together as long as they're little. See the little ends there? Those are called index. Those are called indices. That's plural for index. As long as the indices are the same. If you have a fraction inside, you can break it up into two pieces, into two radicals. Look at this one. If you have a radical inside a radical, you can make it one big radical by multiplying their two indices, the indexes together. I can't believe I just said indexes when I just told you it's indices. Okay, so this one, if the exponent inside is the same as the index, you can just pull that number out. That's very important. If the index is the same as the exponent, you can just pull the number out. Look over here. The fifth root of -5 to the cube root of -5 to the third power. Because the index is the same as the exponent, you can just pull that -5 straight out. Look at this one. Fifth root of 2 to the fifth. Just 2. That's if n is odd. Now, if it's even, you got to take the absolute value of that number. And we're going to talk about this one in class quite a bit tomorrow, so don't worry if you don't get this exactly. But if it says fourth root of something to the fourth power, you can just pull that straight out, but you must take the absolute value of it. And the reason for that is you can't take the even root of of a negative number. It must be positive, take an even root. And we'll talk about that more tomorrow. Don't worry about that too much right now. All right, let's try a couple here. This first one says the cube root of x to the fourth. I'm going to teach you how to simplify this a little bit differently. You've been taught before probably. I want you to take that 3 every time. Take your index and divide it into your exponent if it's a variable. So 3 goes into 4 one time. I want you to take 1x out. Whatever the remainder is when you divide it, like 3 goes into 4 one time, the remainder is 1. I want you to leave 1x inside. I don't know what just happened there. Sorry about that. The whole screen just moved. All right, so sometimes it does that to me. Let's try the second one down here, see if I can make it be still this time. I'm going to take the fourth root of 81 first. That's 3. Divide. 4 goes into 8 two times. Take 2 x's out. 4 goes into 4 one time. Take 1 y out. Now, the y needs to be an absolute value because it must be positive. The reason I didn't put the x squared in absolute value is because it's an even exponent. X squared, if it's an even exponent, it has to be positive. No worries there. And again, we will talk about this situation more tomorrow in class, so don't fret about that too much yet. Okay, fraction exponents. When you see a fraction exponent, the bottom is the root and the top is the power. So if you see like a to the 1 over n power, it just means the nth root of a. Like if you see 2 to the 1/2 power, the bottom number of your fraction is the root, so it's a square root of 2. If you have a fraction that doesn't have a 1 in the numerator, like down here, let me blow this up just a little bit, like this one, you have an m on top and an n on the bottom. All right, the bottom number is the root, so it's the nth root. The top, the numerator, is the power. So we're going to say this a lot tomorrow. The bottom is the root and the top is the power. The bottom is the root and the top is the power. I love saying that. All right, for example, when I see this one, 4 to the 1/2 power, the 2 is the root. So I'm thinking, what's the square root of 4? Which is 2, and the 1 is the power, so 2 to the first power is 2. That's all you do there. When I look at this one, I'm thinking, okay, the bottom is the root, the 3 root, or cube root of 8. The cube root of 8 is 2. I still have the 2. 2 squared is 4. That's all you do. Here, bottom is the root. I'm going to take the cube root of 125, which is 5. I still have the -1. Don't forget from yesterday what a negative exponent does. It flips things, so it's 1/5. Getting close. A to the 1/3 times a to the 7/3. All the exponent rules still apply, even to fraction exponents. So you just add the exponents here. You get a to the 8/3 power. That's all you got to do. This exponent is outside. It goes for everything inside. So we get 2 to the 3/2 power. A, remember, power to power you multiply. 9/2 power. B, power to power multiply. That'd be 12/2. 12/2 is really 6. So 6. All right. All right, this slide has some interesting things on it. When you're going to multiply radicals together, especially when they have different indices, like that's a square root, that's a cube root, one really smart thing to do is change them to fraction exponents. Like make that first one 1/2 power because it's a square root. Let's make the second one 1/3 power because it's a cube root. And then you can just do this. You can say, okay, I can multiply now. 2 times 3 is 6. When you multiply the same base, remember, we just add the exponents together. So 1/2 is really 3/6. That's really 2/6, which gives you 5/6, which is really the same thing as this right here. 6 on the 6th root of x to the 5th. So that answer's fine. That answer's fine too. Just a good way to, changing those to fraction exponents really helps sometimes. Let's look at the second one down here. This one, if you think about it, this one great big square root. So I'm going to make one big parentheses and do 1/2 power because it's a square root. Now, one of the x's is, just in the big square root. The other x has its own square root, which is another 1/2 power. So remember, the outside exponent goes for everything inside. So the first x is going to be x to the 1/2. The second x is going to be x to the 1/4. And remember, when you multiply the same base, you just add the exponents. So if you add 1/2 and 1/4 together, you get 3/4, and there you have it. Or you could also write it this way, the 4th root of x cubed. Either way you want to go there. One more slide. All right, the last slide is about rationalizing what's called rationalizing denominators. I hope you remember from Algebra 2, you're not allowed to leave a radical in your denominator. If it's just a square root, the best way to go is just multiply by whatever the square root is. So it's going to be 2 on 3 on top. On the bottom, square root of 3 times square root of 3 is just 3. No big deal. The second one, because it's a cube root, to be able to pull that number out, this is on that first slide we did. This is the property. You're allowed to pull a variable out or number out if the exponent and index match. So that means I need 3 x's inside. Right now there's only 2 x's inside that radical, that cube root. So I'm going to put one more x with it. And if I do that on the bottom, I don't know why I wrote that on the top, you must do the same thing in the numerator. So I will get cube root of x over cube root of x cubed, which means now I can just pull that x out in my denominator and just get x like that. All right. And the last one here. I'll split it up. So I have the 7th root of 1. I guess I should have done this on those other ones too. And the 7th root of a squared. Now, I have 2 a's in my denominator. To be able to pull the a out, I need to have 7 a's, which means I need 5 more. So I'm going to multiply the top and the bottom by the 7th root of a to the 5th. All right, so in my numerator, I will just get 7th root of a to the 5th because I multiplied it times 1. And on the bottom, I'm going to get the 7th root of a to the 7th. Now, because the exponent is the same as the index, you can just pull that a right out of there. And I have this on my numerator, on the denominator, I just have a. All right, and guys, that's pretty tough right there, and we'll work on that tomorrow, I promise you. You'll get good at it as we work on it together. So, hope it made some sense. Look forward to seeing you as always. See you tomorrow.